Let's take a look at this example. There are many different ways to solve this problem, but I'm going to start from solving the total current. I'm going to find the total current in this circuit by using Ohm's law. I total in this circuit is going to be equal to the current which will go through the resistor, and is going to be also equal to the current which will go through the capacitor. Why? Because this is the series circuit. Okay, in series circuit, current is always the same at every single point of the circuit. So how I can find the total current? By simply dividing voltage source by Z total. Voltage source is equal 200 volts and Z total is equal 1 kilo ohm. 200 volts divided by 1 kilo ohm is equal 200 milliamps. This is my total current, but please notice that this current is missing the angle. We are going to find the angle later on. Next, because I have current and I have given power at the resistor, I can find the resistance, because formula for power says that power is equal I square times resistance. In order to find resistance, I have to divide this formula on both sides by I square. I square. I square and I square will cancel out, and I'm going to end up with R equals power over I square. This is equal P, power equals 20 watts over I square, where I is equal 200 milliamps to the second power. Use the calculator. You're supposed to get the value of 500 ohms. This is my resistor. Okay. Next, we are going to find the angle, because we have to find the angle in order to have our answers correct. So you have to remember that the power factor formula says that power factor is equal cosine theta, and this is also equal resistance over the total impedance. Okay, please notice that we found the value of the resistor. We have given the total impedance. This is total impedance. So from this formula we can find the angle. Okay, because cosine theta is equal R over Z total. So if I'm going to find the inverse of my cosine, and I'm going to use R over Z total. Please notice that I do always formula first. I want you to do always formulas first. Next, plug in the values. So I have theta equals inverse cosine, and I have R equals 500 ohms over Z total, which is equal 1 kilo ohm. This is equal 60 degrees. But please notice that this is RC circuit. Anytime we'll talk about RC circuit, the angle theta is going to be always negative. Okay, I add the negative sign because this is RC circuit. If you are going to draw the impedance diagram, right? So if this is resistor, X of C, XC goes always with angle of negative 90 degrees. So if you want to find Z total will go always with negative angle, and this is my theta. That's why I have negative sign over here. So it means that my Z total is equal 1 kilo ohm, and has angle of negative 60 degrees. This angle which we just found. Next, we're supposed to fix the situation with the current. Okay, so let me write over here. I total is equal voltage source over Z total. Okay, our voltage source is equal 200 volts, and anytime angle is not given, there is angle of 0 degrees, and Z total is equal, we said 1 kilo ohm and angle of negative 60 degrees. And if you are going to divide these two values by each other, you are going to end up with 200 milliamps and angle of 60 degrees. So right now I know that my current has to go with angle of 60 degrees. And this is true because in the series RC circuit, current is going to lead the voltage source by certain value, okay? In this case by 60 degrees. So we found so far I total, we found angle theta, we found R, we found all currents, so we can find right now X of C, right? Capacitive reactance. You're supposed to realize that this is series circuit, so total impedance Z total is equal R plus X of C. Now we're supposed to find X of C. In order to find X of C, we're supposed to use algebra. Simply, what we're supposed to do, we're supposed to move R to the left side, and we are going to end up with the formula X of C, or Z of C, because some books use X of C, some books use Z of C, equals, in this case, Z total minus R. We found Z total equals 1 kilo ohm and angle of negative 60 degrees, my Z total, minus R, and we found that R is equal 500 ohms. Use the calculator and you're supposed to obtain the value of 866.02 ohms and angle of negative 90 degrees. This is the impedance, or also called capacitive reactance, of my capacitor. Next, we can find voltage across the resistor. In order to find voltage across the resistor, I'm going to use Ohm's law. VR is equal current which goes through the resistor times the resistance of the resistor, where IR, we said, is equal 200 milliamps, and don't forget about the angle, which is 60 degrees, times the resistance of the resistor, which is equal 500 ohms. Okay, this is equal 100 volts and angle of 60 degrees. This is the voltage across the resistor. Voltage across the capacitor, VC, I'm going to also find by using Ohm's law. So write formula first. VC is equal IC times X of C, where IC we found is equal 200 milliamps and angle of 60 degrees times x of c, 866.02 ohms, and angle of negative 90 degrees. Okay, multiply them together. You're supposed to get the value of 173.2 volts and angle of negative 30 degrees. So, please notice that if you are going to draw the phasor diagram for voltages, you are going to have voltage across the resistor, VR, equals 100 volts, approximately 100 volts, this is VR, 100 volts and angle of 60 degrees, and we have voltage across the capacitor equals 173.2 volts and angle of negative 30 degrees. Okay, so approximately this has to be, okay, my picture doesn't show this very clear, but this has to be angle of 90 degrees. This is VC equals 173.2 volts and angle of negative 30 degrees. If you want to make your graph more accurate, I recommend to convert the polar forms to rectangular form and use the rectangular coordinates to find the points, right, and connect that points to the origin, and your diagram is going to look very accurate. But at this moment, we're going to stay with this diagram. So everything looks good so far because voltage across the resistor is leading the voltage across the capacitor by 90 degrees. If you want to prove that this is correct, let's say if you want to prove this mathematically, you simply write that voltage source has to be equal to the sum of voltage across the resistor plus voltage across the capacitor, where voltage across the resistor we said is equal 100 volts an angle of 60 degrees plus voltage across the capacitor 173.2 volts and angle of negative 30 degrees. This is equal 200 volts and angle of 0.0007 degrees. So you can say that voltage source in this case is equal 200 volts and angle of 0 degrees. So this is another proof that our answers are correct so far. Next, we're supposed to find the capacitance. In order to find the capacitance, I'm supposed to use the formula for the capacitive reactance. X of C is equal 1 over 2 pi Fc. Solve this formula for C. So C is equal 1 over 2 pi F X of C. Okay, you're supposed to use the algebra. Plug in the values and you're supposed to have 1 divided by 2 pi times the frequency, which is equal 1000 over pi hertz times X of C. And we found X of C equals 866.02 ohms. Okay, close the parentheses. Pi and pi will cancel out. Use the calculator. You're supposed to get the value of C 577.35 nanofarads. So this is my capacitance. Next, we're supposed to find the power factor. Power factor is equal cosine theta. Okay, so cosine and angle theta we found is equal 60 degrees. So cosine of 60 degrees is equal 0.5 And because in this circuit, right, the current, the load current, I mean the current which will go through the resistor and capacitor leads the voltage source, that's why I'm supposed to add to my power factor word lead. In some books you are going to see leads, leading, lead. It means the same, okay? So next we're supposed to find the reactive power, QC. QC I'm going to use from using the formula IC square times X of C, because this is my voltage source and it's not specified that this is peak or peak to peak, so I'm going to treat this voltage like an RMS. So the current which I found is also RMS. That's why I'm going to use this formula, IC square. So IC is equal 200 milliamps to the second power times X of C, which is equal 866.02 ohms, is equal 34.64 volt amp reactance. Okay, so this is the reactive power at the capacitor. Next, we're supposed to find the apparent power. In order to find the apparent power, I'm supposed to write the formula first. S, which represents my apparent power, is equal I total to the second power times Z total, where I total is equal 200 milliamps to the second power times Z total, which is equal 1 kilo. Okay, use the calculator. You're supposed to get the value of 4 VA, volt ampere. This is my apparent power. If you want to draw the power triangle, you're supposed to draw the phasor which represents the true power, P equals 20 watts. Next, we found that QC is equal 34.64 approximately. I'm going to draw like this. This is my QC, which is equal 34.64 VAR, and my S is over here, so this is S equals, we found 4 VA, and this is your angle theta. Students very often ask me what this angle represents. What angle is this, okay? So this angle, which you are going to get from the power triangle, is the angle which we used in our problem. This is the angle which we used next to Z total, okay? If you want to check if this is true, simply you can use any of the trigonometric functions, because when we have all sides given, we can use any one. I prefer to use tangent, so in order to find theta, I'm supposed to use inverse tangent, and tangent of this angle is opposite side divided by adjacent, so I have QC over P. Okay, so I have theta is equal inverse tangent, and QC is equal 34.64 VAR over 20 watts. Okay, I'm not going to care about the units, simply use the numbers, and you're supposed to obtain the angle of 60 degrees. But don't forget, this is RC circuit, and because we have series RC circuit, we're supposed to add negative sign into it. Okay, so we can say that the problem is solved.